All right, so these are the notes for matter basics and classifying matter. Chemistry, the class itself, is the study of matter and its interactions. So we need to know what matter happens to be. Anything that is something that we can describe as stuff would be called matter. So that's anything that has mass, volume, or can show inertia. Mass is something that you can measure on a balance. So if you could put something on a balance and it weighs something that has mass. Volume is if it takes up space, and inertia is the concept that if it starts moving, it's going to continue moving, or if it isn't moving, it's not going to just start moving on its own. So the basic building block of all matter happens to be atom, and that's what we care about in chemistry class because that's the smallest piece of matter that still retains its own properties. And they come in different types of elements. So if you look at the periodic table of elements, those are all different kinds of atoms, and we can't break those down any further and still have the same set of properties of that specific element. So we can classify matter into two general groups. We can either have a substance, which is pure, or a mixture, which is two or more, typically two or more substances that are physically combined, and they're going to contain or retain some of their own properties. Not all the properties stay the same because, like, for example, if you were to take sugar, which is white, and dissolve it in the water, that white of sugar is going to go away. However, the sweetness of sugar is still going to be there inside that water when you make a sugar-water mixture. So inside of a mixture, the individual substances retain at least some of their own properties, if not all of them, and they are physically combined. That's important to note, but physically combined. And then again, substances are pure. There's only one type of particle inside of that container. So for example, if we were to use a microscope and zoom in, we could have an element, and that element would have only one type of atom, Or we could have a compound, which we're going to talk about here in a little bit, which could have two different types of atoms, shaded and unshaded. But since the container only contains this type of particle, that's a substance. Or if the container only contains this type of particle, that's also a substance. If the container contains both types of particles, that would be a mixture because these particles are different from one another, and they are not chemically combined, which is what we're going to see next. So going back, the other way that we can, we can further break down classifying matter by saying that we have elements or compounds, which is what I just spoke about. So elements, or atoms, are the smallest type of matter that still retains its own properties. For example, things like sodium, hydrogen, which comes as two hydrogen atoms stuck to each other. So it might look something like this if you could look at it underneath a microscope. Or we could have a lot of the same atoms stuck together, like carbon, where there's 60 copies, that makes something called Buckminster fullerene, which is a soccer ball looking structure. On the other hand, a compound is when you have two or more different atoms that are chemically combined with each other, like sodium chloride or water or C6H12O6, which hopefully you recall as glucose. All of these, though, are chemically combined. If it's a compound, that means those atoms are stuck together. So if we're looking at water, chemically combined. If we're looking at sodium chloride, chemically combined. So that's the substances. We can break down substances into elements or compounds. Now, mixtures can be either homogeneous mixtures or heterogeneous mixtures. So we're describing the kind of mixture. Is it the same throughout, uniformly mixed like a homogeneous mixture, which is also known as a solution? Or are we talking about a heterogeneous mixture where we can see some distinct differences in that mixture? So microscopically, a mixture has to have two different substances. So the shaded and unshaded, we could have some of those. And then we could have the just shaded circles. If we have them kind of interspersed like so, that might be microscopically what a homogeneous mixture looks like, or a solution. However, if we can separate them, for example, the shaded unshaded particles are in one distinct region, and the just shaded particles are in a different region, that might be microscopically what a heterogeneous mixture happens to look like. Looking at some additional examples, actual substances. So, for example, sulfur, it's a yellow powder. That's an element. The only thing that's inside of this is the atom that is S. So that's the only thing that's inside of that container. Or, for example, tin. The only atom that's in there is the atom that's represented as the elemental symbol Sn. So that would be just like that. Table salt, NaCl, something that we're pretty familiar with, it has a sodium atom bonded to a chlorine atom. So that might look something like this. And then lastly, a beaker of water here, which has hydrogen stuck to oxygen in this chemical formula, and we would see that microscopically as the, turn it this way, Mickey Mouses. Now, we can add stuff to water, for example, sodium chloride. If you recall your earlier science classes, you probably mixed salt and water, and you know that's going to dissolve, and that's going to look the same throughout once it dissolves. You're not going to see any different regions. It's uniformly mixed, and that salt's going to go away if we give it enough time. But you won't see any different regions. So that would be a homogeneous mixture because there's two things in there. For example, that would be the Mickey Mouses and the sodium chloride compounds. So we would have it like so. Uniformly mixed. Uniformly mixed, there's no distinct regions inside that beaker. Or we could take water, the Mickey Mouses, and we could add some of the tin to that. Now, I think you might recognize that we're not going to be able to dissolve the tin into the water. It's going to just stay there the whole time. So we're going to have a region of water, and we're going to have a region of tin atoms, and they're not going to mix together. So that would be a heterogeneous mixture where we see distinct regions, two different substances physically combined. Definitely going to be a heterogeneous mixture. It's also worth noting we don't have to just talk about straight up what we would call chemicals. We could have a heterogeneous mixture or even a homogeneous mixture where it's not chemicals, like Kool-Aid is a homogeneous mixture, or milk is a homogeneous mixture, whereas like a chocolate chip cookie or pepperoni pizza are heterogeneous mixtures. And then of course we have paper clips of different sorts and also some rubber stoppers. That's a heterogeneous mixture. So that's classifying matter. There's a couple graphics that we can talk about here. For example, we can say matter can be broken into substances and mixtures, going through the different definitions. Substances are broken into elements and compounds, and mixtures are then broken into homogeneous mixtures and heterogeneous mixtures. Remember that a homogeneous mixture is also known as a solution, and there's a specific type of homogeneous mixture called an alloy, which is a mixture of metals, such as brass. It puts the beneficial properties of the metals together. So, for example, if you were to take gold, very pretty, precious, however, it's a soft metal, so it's not very good for jewelry. You need to add some other metals like silver that make it more durable, so it works better for jewelry. Also, a specific example of a solution that's not made out of liquids, most of our solutions are made out of liquids, would be something like air, which has a lot of different gases such as water, vapor, carbon dioxide, oxygen, of course, mostly nitrogen though. Most of our atmosphere is nitrogen. We can also use these words heterogeneous and homogeneous. Homogeneous just literally means the same appearance, and then heterogeneous is going to be there's differences in appearance. So really an element, a compound, and a homogeneous mixture are all homogeneous materials because they all have a uniform composition. It's just that a homogeneous mixture has a uniform composition. with the added definition of mixture, two or more physically combined substances. And then a heterogeneous mixture, of course, is going to be heterogeneous because you can see differences.